Boeing was an engineering company long before it was a stock market symbol. The company's reputation was earned inside the vast factories surrounding Seattle, where thousands of engineers, mechanics, and test pilots labor over aircraft that simply could not fail. In aviation, no failure was ever just a minor one. A bolt, wire, equation, or piece of code carried hundreds of human lives. Boeing accepted this responsibility. The company made the planes that reshaped commercial aviation: the 707, which brought millions into the jet age; the 747, which would become an icon; the 737, the world's most reliable jetliner. Airlines believed in Boeing. Pilots trusted Boeing. Passengers walked up to its planes without even noticing the name near the door. That intangible trust may have been the company's most important product. The original 737 first flew in 1967, when airports were smaller, engines narrower, and air travel was mostly for the rich. Boeing did not replace it but instead gave it new engines, updated avionics, stretched its fuselage, designed more efficient wings version after version while retaining enough of the original architecture that airlines' costs for training, maintenance and operation could be kept down. Pilots could easily transition to a new 737 from an older one. This continuity provided enormous leverage. Airlines weren't just buying an aircraft, but an entire system centered around it: pilot pools, spare parts and mechanics, training programs and flight schedules. Yet, during these decades, Boeing too was undergoing a transformation. Following its merger in 1997 with McDonnell Douglas, a struggle for control of the company's soul ensued. According to internal and external observers, the culture of engineering first clashed with a new management paradigm that emphasized shareholder returns, cost-cutting and financial performance. Engineers still built the planes, but financial metrics and corporate directives set the stage on which they operated. The battle was largely invisible, however, until another manufacturer produced a jetliner that was a competitive threat. And then time began to accelerate. On December 2010, Airbus declared the A320neo. That name was like a commonplace remodel. However, what they delivered offered airlines some incredibly beneficial, more effective engines at cheaper fuel costs, without forsaking the A320 familiars they currently loved. Fuel cost airlines the maximum amount as other expenditures. And also an infinitesimal difference might save enormous amounts for some aircraft fleet. Therefore, orders rapidly started going in. Boeing had actually begun experiencing a perilous choice. One option was a complete scratch, brand new replacement for the 737. This new airplane may include a modern framework custom designed for future engines. However, any type of new commercial flight might consume closer to a year's and also billions to create. Boeing's response was already in place. The corporation had actually no possibility for even more postponement. Stress started heating up significantly in 2011, with American Airlines prepare a massive order consisting of countless Airbus airplanes. Dropping a major U.S. client wasn't merely a pecuniary loss. It would certainly show the whole globe that Airbus held the high ground. Boeing replied to the crisis by dedicating itself to creating an even more fuel-efficient 737 quickly. The resulting airplane, the 737 MAX. The approach on paper: mount more modern, economical engines onto the established 737 structure. Airlines would get enhanced efficiency without the expenses and also confusion of integrating an entirely brand new airplane sort. A lot more critical, Boeing intended the MAX to fly adequately such that the pilots would not have needed extensive and also pricey full-motion flight simulator training, as an example. This commitment was a huge aspect. Flight simulator training costs money, time and also personnel off the flight deck, gear acquisition and also planning. Minimizing the retraining needed would certainly permit Boeing to make the MAX easier to acquire than a fresh model. There was an engineering hurdle presented by the brand new engines. Because of their much larger size than the preceding variation, and also since the original airplane rode quite reduced to the ground, engineers needed to mount them higher up as well as farther ahead on the wings. This modification, the change, had a significant effect on exactly how the plane behaved under specific conditions, for example, with the nose raised high as well as the plane nearing stall. Boeing would certainly maintain the outdated aircraft's market identity. And also the software would assist keep its flying attributes familiar. This is where the MCAS enters the image. MCAS, Maneuvering Characteristics Augmentation System. MCAS was intended to automatically apply nose-down stabilizer during certain high angle of attack situations in an effort to make the MAX handle like an earlier 737 and meet certification requirements. Software designed to assist a pilot is not inherently dangerous. In any given moment, modern airplanes rely heavily on computers, sensors, and automated systems. It's the assumptions surrounding the software that is dangerous. The first version of MCAS could rely on a single angle of attack sensor which measures the angle between an aircraft's wing and oncoming airflow. If the active sensor reported false data to MCAS, the system could believe that the aircraft's nose was dangerously high, when it wasn't. Based on the false signal, it could command the nose down. Investigators would examine not only how MCAS worked, but how Boeing and the Federal Aviation Administration, FAA, assessed its risk. In a part of the certification process the FAA delegated to authorized Boeing personnel, it expected the manufacturer to analyze the risks associated with the safety of its own product, under extreme commercial pressure to keep the MAX commercially competitive. With time, MCAS grew in power and sophistication over earlier concepts. However, pilots were not given adequate explanations during the aircraft's rollout. The word MCAS was not used in the original Flight Crew Operations Manual. For many pilots there was no document on which to study the system, because there was no indication it existed. Boeing emphasized that pilots knew how to cope with unwanted stabilizer movement. Training was thought to be sufficient to allow trained flight crews to identify the problem and then apply existing procedure. However, real emergencies do not present themselves as simple test questions. They arrive with alarms, confused instrument displays, external physical forces, radio calls, and rapidly dwindling clock time. It's the process of discerning what is happening in the aircraft, and then deciding the right action that matters. Internal pressures within Boeing related to schedules, certification, training, and the competitive pressure to keep the MAX selling, continued to push the airplane forward. Every delay was a threat to orders. Every new training mandate weakened the sales case. Every substantial design revision offered more time to rivals at Airbus. The MAX entered service in 2017. Boeing seemed to have an answer to its Airbus problem. The profit and loss statement would balance with the orders. The hidden risk resided within the aircraft. October 29, 2018. Lion Air Flight 610 departs Jakarta, Indonesia. Shortly after takeoff, the pilots lost control of the airplane. Flawed angle of attack data led to conflicting warnings, and MCAS pushed the nose-down movement of the stabilizer time and again. The crew fought to climb the plane. It then dove into the Java Sea. All 189 aboard were killed. Following the crash, attention focused on MCAS. Pilots worldwide discovered that the MAX contained an automated system most of them hadn't learned much about. Boeing issued reminders on how crews should handle stabilizer movement if it behaved unexpectedly. The company and regulators worked on a software fix. But the global MAX fleet continued flying. The public was assured the plane was safe. Then, less than 5 months later, Ethiopian Airlines Flight 302 departed Addis Ababa. Again, an angle of attack sensor provided false readings. The nose was driven down repeatedly. The crew struggled to react to this action as the airplane gained speed and the forces on the control yoke increased. 6 minutes after takeoff, the airplane dove into the ground near the city of Bishoftu. All 157 people on board were killed. Together, the two flights had claimed 346 lives. These were no longer isolated accidents. Two identical airplanes had crashed in similar, alarming ways. Regulators around the world grounded the MAX. China moved first, followed by other countries. The U.S. initially resisted an immediate grounding, but ultimately grounded the airplane in March 2019 after a growing amount of evidence and international pressure mounted. Hundreds of MAX airplanes were parked. New deliveries ceased. Flights were canceled. Boeing's flagship commercial airplane became the center of a global crisis. Investigations showed that the crash was not a single error, but a chain of failures. An powerful automated system was reliant on data from just one sensor. The system's behavior, under intense pressure from the forces acting upon an accelerating airplane with multiple warnings blaring, was more demanding than engineers assumed would be manageable by humans. The existence of MCAS and how it functioned had not been well communicated, and the approval process failed to fully expose how the system would perform when confronted by real-world scenarios. As the National Transportation Safety Board pointed out later, there was a disconnect between the assumptions made during certification and the actual experience of pilots faced with numerous warnings. That's a crucial difference. On a spreadsheet, a pilot may have seconds to figure out the likely source of a known malfunction. In the chaos of a moving cockpit, with all the noise, the force, the uncertainty, the fear, that second count is different. Boeing had assumed a certain human reaction to an automated system. Instead, it found something else entirely. And by the time the world realized it, 346 seats were vacant. The grounding lasted 20 months in the US. In that time, Boeing rewritten its MCAS software, altered the way the system uses sensor information, restricted the MCAS's authority, changed procedures and supported the implementation of new training requirements. Regulators also undertook further reviews and flight testing. In November 2020, FAA lifted its grounding order after Boeing implemented the required repairs and training, and MAX started returning to service. But repairing the aircraft was only part of the crisis. Repairing the brand and reputation would be even harder. Congressional investigators cited technical failures, faulty assumptions, management pressure, and a failure of regulatory oversight. Internal documents revealed an organization where some employees were acutely aware of program and certification process failures. The company faced lost orders, suspended production, litigation, investigations, and billions of dollars in losses stemming from the crisis and the grounding of its aircraft. Top managers departed. Families called for accountability, pilots called for transparency, and passengers began searching flight plans for the aircraft type before booking tickets. For generations, the name of Boeing represented a silent promise to travelers: you will be safe. Now it represented questions. The tragedy of the 737 MAX was not the lack of talented engineers. The company employed many of the most experienced professionals in the world. The tragedy was that this expertise existed in a context where the marketplace had already prioritized profit over certainty. We need more efficiency, yes, but don't ask us to invent an entirely new aircraft. And we need this new airplane to fly the same as the last just to avoid increasing the minimum training requirements, which is costly for airlines, one engineering group at Boeing wrote internally. At each stage of the MAX development, another layer of complexity masked the compromise made in service of an existing business model. Until the complexity finally made its way to the cockpit. Boeing says it corrected those issues, and the plane flying today is not the one grounded in 2019. Boeing has since implemented software updates, revised pilot procedures and new training protocols along with FAA review and recertification to return the 737 MAX to commercial flight. But the larger lessons extend far beyond the aircraft. You can survive an engineering flaw, software bugs, faulty parts, or procedures can be updated. It is far harder, however, to recover from a culture that encourages people to seek answers based on what management wants to hear. In aviation, safety means an absolute commitment, and not just a slogan emblazoned on a factory wall. It's being willing to miss a deadline, lose an order, irk a customer, or tell an executive that a potentially lucrative plan is no longer feasible. Boeing, trying to chase its competitor Airbus, quickly produced an aircraft designed to satisfy market demand, better fuel efficiency, and the familiar feel of its predecessor while also keeping development costs, time and pilot training low. It all looked compelling. Then came the true price: 346 lives and a generation of faith shattered. The 737 MAX was proof that sometimes the most costly problem a company faces is the one nobody dares to pause to investigate. Welcome to the Noir Ledger, where every fortune leaves a paper trail. And sometimes the price of profit can't be measured in dollars alone.